Hello there. Good to have you again on The Young Inventors. It's a bumper package we have for you today in the show. My name is Treasure Bassi and I am your host. The Skillgy Labless Lab is by all definition and standard a giant in the manufacture and sales of innovative and miniaturized science and technology equipment to make the learning and teaching of the sciences easy, with possibilities of carrying out demonstrations and experiments, not necessarily in a designated location called the laboratory, but anywhere for that matter. Today, we bring you some of Skillgy products demonstration for primary schools. These are learning kits paraded by Skillgy, one of our sponsors at the Children's Expo 2010. Besides, you'll get to see project entries of children and young adults in the areas of power, nuclear, space and security. But we're beginning with Skillgy, the Labless Lab demonstration of primary school learning kits, which they did with the end users of the products.
The name is what? Light microscope. Light what?
Microscope.
Light what?
Microscope.
Why is it called light microscope? I want you to have a look at it. Close up. Okay. It produces what?
Light.
Thank you very much. It produces what?
Light.
Light. Ah. Okay.
Because it has a mirror which reflects.
Good. Because it has what? A mirror that reflects what? Light. Thank you very much. Okay. Who can say any other thing?
It's not heavy.
What?
It's not heavy.
It's light. Good. Clap for him. Okay. Now, this is a kind of model. We call this what? Model. What do we call this?
Model.
Bulb. Electric what?
Bulb.
Bulb. And what do we call this?
Battery.
Battery. And what do we call this?
Motor fan.
Fantastic. Motor fan. Yes. And what do we call this? Switch. Switch. Now, combination of all these things now give us what? Electric circuit. Okay. Now, if I remove one, the circuit is what? Open. The current cannot flow. What do you think that supplies the current?
Battery.
Good, battery. Yes, battery. Now, if I close the circuit, the bulb will do what? Show. Okay? Showing that current flows around the circuit. Have you seen this thing before?
Yes.
What is the name?
Okay. Stethoscope.
Stethoscope. Who can tell me the function? Okay.
Doctors use it to check whether somebody is
Fantastic. I would like somebody to stand up. Let's see how it works. Okay. Okay.
It is telling me how my heart beats.
Boom, 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 boom. Good. Get it. The other side.
It's making a noise.
Yes, a noise. A noise. Who can tell me the name of the noise? Okay. Huh? This board will be asking you question and you will be answering the question. Okay? Let me show you how to use it. Press on here and listen to what he's saying. Okay. You are going to press what? Start here. Okay? Press your own start. And press your own start. Okay, press. Good. The mirror will ask you to answer question number 1. Huh? And you have to read question number 1 and you now press the answer. If you get the answer correct, huh, the board will say thank you. But if you fail it, the board will say no, try again.
You read.
High voltage sign.
Oh yeah, you choose the answer.
Uncle, should I choose?
Yes, you can choose.
Try again.
Should I choose?
Try again.
Question. Very good.
Yes, very good.
Okay, so much of Skillgy for today. Next week we'll feature more. We start off in the project presentation with a prototype fuel production machine put together by the duo of Emecheta Nzube and Idris Zubairu. and entered in the senior category by NTA Channel 5, Abuja. The project is jointly presented by the duo.
My name is Zubairu. I'm here to present this project. With me is Idris. We are from Government Science and Technical College, representing NTA F.C.T. Abuja. Here we have a project entitled Prototype Fuel Production Machine. The aim of this project is to enable Nigerian folks to understand that crude oil is not the only source that fuel can be produced. We can also use raw materials and food crops that we consume to produce fuel, such as cassava, palm wine, maize, sugarcane, as well. So this is our raw material. This, as you can see, is palm wine. First, you have to allow the palm wine to ferment for 7 days. So as to make it quick, we add sugar as a catalyst, so as to ferment very quick. Now, in this machine, it's divided into two components. From here to that side is the heating chambers. In this heating chamber, it have 3 sources of power. This is the electrical heating chamber, which we are using right now, and this is the local heating chamber that uses charcoal, and this is the kerosene air pressure that we can also use as alternative if these sources are not available. Now, this is the cooling system that will help that after putting your feed inside here, your material inside here, then the material, the fuel content of that material will be the first to evaporate as vapor. This must be airtight so that the vapor cannot turn into air and we will not see it again. So the vapor passes through here and enters into this cooling chamber. As you can see, the cooling chamber is designed in a way that if there is no electricity, that we can also use block to help cool the cooling chamber, cool this system. So if the hot air passes through this place, this cooling chamber will help condense it back to liquid. Then it will now come out from here as a fuel. Then if you want it to be highly flammable, then you still recycle it back. Then you now get your actual fuel. From here, I would like to hand over to my colleague to explain more of this to you.
As he said, we have 3 types of heating chambers here. This is the electrical heating chamber, the local heating chamber, and the kerosene air heating chamber. This local heating chamber contains the heating hearts here, in which you put the charcoal inside, and the furnace here where you pour your raw material, and the bellon in which you use in pumping air to this heating hearts to allow combustion to take place. This bellon is turned clockwise in order to pump air to this to the heating chamber here. Then here, this is the kerosene heating. This is the kerosene pressure air. It contains kerosene, and this pump here is used in pumping air in order to allow atomization to take place. That is mixing. There will be a mixture of air and kerosene in order to provide a pressure that will help in pushing the kerosene but to this burner here, where you light way you light your fire to provide heat. And in case if you don't want to use this furnace is being transferred to this place, that in which the furnace that contains the raw material that will be heated to 70 to 75 degrees, and when it's heated to 70 to 75 degrees, the fuel content of the material you use will be the first to evaporate and turn to vapor. As you can see here, it's coming out as vapor here. So it goes into this. Let's say you are not using this one, you are going to connect this to this one here. So the vapor coming out here, as you can see, will pass through and enter the cooling chamber where condensation takes place, as he said. When condensation is taking place, the vapor is being trapped. That is, they are removing heat from the vapor, and in that process is turning back to liquid. So the liquid is being passed here as the fuel, and when you want to get the real highly flammable fuel, you have to recycle the product you get here in order to get the real highly flammable fuel that can be used for automobiles.
So in actual fact, what you're saying, the process we are saying, flames coming from there, condenses inside this cooling chamber. So
this channel is provided in order to help in cooling. That is, here is the condensing unit where cooling takes place. This pipe here is connected to this unit here. Here is the compressor this is the condenser, and here is the fan blower that helps in providing cooling effect in this cooling chamber here.
So the fuel is gotten from the cooling.
Yes, sir. It drops here. Yes, sir.
Okay. What are your raw materials?
Okay. The raw material where we have cassava, sugarcane, palm wine, and maize. Those are
mix all of them together.
No, you can only use one out of it. You can use either cassava or palm wine.
This is extract from palm wine.
Using palm wine.
This one is the extract from palm wine, and this one is the extract from sugarcane.
Okay, so as it is now, is it already a fuel?
No.
So what do you do else with this?
We'll recycle it back.
How?
This is the first stage. We'll still reheat it and put it back.
You repeat the process.
Yes.
How many times will you do it before it becomes?
2 to 3 times. Then.
2 to 3 times.
Yes.
Now tell me, if you now get your end product, what kind of fuel are you seeing?
The fuel that we'll get can be used for generators, automobiles, or any other mechanical appliances. So I can call it petrol. That's what we are going to get after heating all this process, and it can burn.
Have you tried it on any appliance?
Yes, sir.
Yes, we've tried it at Old Parade Ground. So we put it in generator, and the generator is still working. Yes.
So your raw material can either be
Cassava, palm wine,
And sugarcane.
that's what you have in this chamber.
What we are using now is palm wine.
Yes, sir. Palm wine.
Are you also doing both the electric grown one and the manual together?
Yes. No.
It's
These
just an
alternatives if
These are just
there is no power.
But I can see mist coming out of this.
Yes.
We just put it there
Put
to
it
demonstrate
to
that it's working.
Little John Hollins in the junior category from NTA Katsina, Katsina State, has this mighty dream of building a nuclear power station. For the starters, however, he has presented this model, an idea he said he picked up from a book.
My name is John Hollins and I'm 8 years old. I came from Katsina State and the NTA station that brought me is from Katsina.
Good. So what is this your project? What is the title of your project?
Nuclear power.
What do you mean nuclear power? What do you mean?
Nuclear power simply means the power that is generally electrical and is produced from controlled nuclear reaction.
Good. So what are these things? Can you tell me what they represent, each of these things?
This is the power plant, and this is the reactor blocks, and this is the control room where all the activities this is the control room where all the activities of the nuclear power will be controlled, and this is the distribution pole that will be used to distribute electricity.
So you meant this as an electricity generating station?
Yes.
Okay. Have you seen something like this before?
Yes.
Where?
In my computer, in my personal computer.
Who helped you to construct this, or did you do it alone by yourself?
It was my teacher who helped me.
Okay, what did the teacher do with you? Did you tell the teacher what you wanted to do?
Yes.
So what did he do for you?
He's the one that when I checked it on my computer and I told him, then we now got aluminium, shoe hooks, nail, hammer and scissors to construct.
But you knew what you wanted to do?
Yes.
Okay, so what did you do? What did your teacher do?
The teacher told me how to do it and I did it myself.
Okay.
My name is Fatima F. Mahmoud.
My name is Hassana Alifa from Mariam Babangida Girls Science College, Mina, Niger State.
My name is Chinazom Ezomuna. I'm from Brightway College, North Bamakodi, Benue State.
My name is Akindele Adamilola from Christ Gardiner School, Ado Ekiti.
Durojaiye Emmanuel's project is a security light remote control switch to guarantee proper security to occupants of his prototype estate. It was entered in the senior category from NTA Ilorin, Kwara State.
My name is Durojaiye Emmanuel from University of Ilorin Secondary School. I'm here to present to you an electricity device which goes to security. This is a remote control light that will show you the intruder. You can use it to get anything from far distance. You may put this one inside your sitting room, and this one may be inside your living room. So you just put it there. From that far distance, you can control it there and you on it there. This uses electricity, while this one uses dry cell battery. So when you fix it now, let me show you an example now. On it here, so I'm going to on this remote control light. So I've on it now, so I'm going to start the work with it now. Generate this one, then do it now. So I'll show you how I'm going to work it now. I've already on the two now, so I'm going to do the work now. I'm going to on this. When I press there, the light is going to on. The light is being on now. I can switch it off through this place. So it's just like a remote control. This is how to switch it on. Then switch it off. Yeah. The sense of this thing is that it's by sending it from far distance. That's true. Standing up and going to the switch is going to be a difficult. We have many people that they have backbone, they have spinal injury, so they may not be able to stand up. They may just sit down and have their switch here and control it from far away distance. So it gives easier thing to do than just moving around and controlling it. So it's easier. It's just as if a remote control. This has a mini transmitter and this has a mini receiver. That's just it. I got this idea from one of my brothers in university. He's in engineering, so he was doing his final projects. So when I now did this, so I now got to school. My teacher now told me something about this. Then I now told him that I can use this and do an electricity security device that can help people from far distance to use it. Then I asked from my brother what was the thing he used. He told me everything. He told me he used bright
so essentially your brother did it?
No, I did it myself. He just told me where he did it and where he bought the equipment. So I went to school with my teacher. We did it together in the school. So she was there. She taught me some other things with it. So I did it in school. The reason why I did this thing is that for people who are sick, like people who has back spinal injury, that cannot stand up from where they are, there might be something disturbing them inside their room. Instead of them moving around to switch the thing, they can just have this from far distance and on it, so they will see what they have. If they want to finish using it, they can just switch it back.
Okay,
again.
tell me, can this one switch off the whole lighting system in the house?
Yes, sir.
Or one bulb at a time?
It's not a bulb at a time. It can do it in many places. You just fix it anywhere you like it with this. Then you have your remote control anywhere. This has a mini transmitter, so you put the receiver in anywhere you can put it. Then you just be operating it one by one through the antenna. You concentrate it there. It has a
But how much does it cost to produce this pair?
It doesn't cost a lot.
So you can have one remote control and then you have the receivers differently. Is that what you're saying?
Yes, sir.
Several receivers and one
remote control. Yes, sir.
We'll end up the program today on Ezeani, Elochukwu's rocket aircraft launcher. It's a project entry in the senior category from NTA Asaba, Delta State.
My name is Ezeani Elochukwu. I'm from Delta State. Okay, my project title is a rocket aircraft and a rocket itself. Coming to this rocket now, you can see it's made of paper. Here is the position of the nose of the rocket. Here you call this place inside the combustion chamber. This is the launcher. This is the fuse, the safety fuse. Here is the nozzle of the rocket engine. Here this rocket works based on the Newton's third law of motion, which states that for every action there is equal and opposite reaction. Here is the fuel. It is made up of sugarcane juice and a strong oxidizing agent known as potassium chlorate. Okay, so after producing the fuel now, you now use it to propel this rocket. When you now put it inside the rocket engine, then you now attach this safety fuse. When you now put the rocket on the ground like this, before launching it, you now have to use a matches or lighter to light the safety fuse. When you light the safety fuse now, it will now carry the charge inside the engine. This charge will now ignite the fuel which is inside that engine. As the fuel burns, gases are released. The chemical energy inside this fuel is now converted to heat energy, light energy and sound energy. The heat energy now will begin to move inside the combustion chamber. As they are moving, the pressure inside the combustion chamber increases. As the pressure increases, the gas will begin to shoot out through the nozzle. As the gas shoots out, it will now act in the opposite direction, which supports that Newton's third law of motion. It is that gas that shoots out now gives the rocket the momentum, and the rocket will now move. Yes. So that's the function of the rocket.
Okay, the aircraft. So
The aircraft is just like an ordinary aircraft, but it's being propelled by the same rocket engine. Here is the nose of the aircraft. This is the cockpit where the pilot stays. This is the wing. This is the rocket engine. This is the elevator. This is the rudder. This is the tail fin. Okay, this is the safety fuses that's used to connect the charges inside the engine. So you can see the nozzle here. Here. This is the nozzle through which gases are ejected. This is the waste. So as we ride the fuse now, the rocket will now, the aircraft will now taxi through the runway. As it moves through the runway, there are 4 forces acting on the aircraft as it's moving. Then the thrust is the force produced by the engine. It propels the aircraft forward. Now drag pushes the aircraft backward, which is associated by the weight of the aircraft. Now lift pushes it upward, while gravity pulls the aircraft downward. So when the force of thrust, that is the force produced by the engine, is greater than the drag, the aircraft now taxis through the runway ahead. When it is moving now, there's air coming in front of the aircraft. As the air is coming, as you can see, this aircraft have a special wing design. It is slanted somehow. So this slant angle of the this wing will now divert the coming air from the front of the aircraft and send this downward. And as the air moves downward, it acts in opposite direction against the wing. That is how the aircraft gathers its lift.
Okay, tell me something. Are you related to an Air Force person? Do you go to the Air Force base? Have you seen a rocket launcher before in your life? What gave you the idea of this?
Okay, you know, I've not been to Air Force school or any airport or so, but normally I don't watch any other movie than Warfing. Yes.
So what is your intention in life? Where do you want to go in life?
Okay, I wanted to become an aeronautic engineer. Yes, so that's where I want to go in life. Yeah.
So this is like a beginning for you.
Yes, sir.
I wish that you would also develop it.
Yes.
And then get it to the highest level.
Yes, sir.
I'm sure you now agree with me when I said it was a bumper package we had for you today at the onset of the program. If you make it a date with us next week, we'll bring you another exciting edition of the program. See you then!